Hello and welcome to this video on complex numbers. This is the second part in the series of videos on complex numbers. If you haven't already watched the first one, I will link it right now on top. Make sure you watch that, where I have cleared some common questions that students have when they hear about complex numbers. Today we will be looking at the properties of these numbers. Properties of numbers means how do they add, subtract, multiply and divide. This is what we will be looking at today. Now if you remember, I told you last time, they are very similar to real numbers. In fact, real numbers are just complex numbers where the imaginary part is equal to 0. So real numbers are just numbers of this form where b is equal to 0. So for example, pi, which is a real number approximately equal to 3.14, is just equal to pi plus 0i. And so we have realized that all real numbers are actually a subset of complex numbers, and in some sense complex numbers are the whole picture. Now today we will be looking into the properties of these numbers. So since they are very similar to real numbers, if you have two complex numbers, let's say this is 1 and this is the second one, then the properties of real numbers apply here as well, and this is just equal to the addition of the real parts. So a plus c plus I times the addition of the complex parts. These are the imaginary parts and this is the real part. AC comes from here and BD from here. So we just add them like two real numbers. We just add them as follows, like this. And then since I is common here, we can separate out the I and write B plus D. And the first term, the first part is A plus C. So this is very simple, just like real numbers. So that means if you want to add two complex numbers, you just add their real parts. That becomes the answer's real part. And the sum of the imaginary parts is the imaginary part of the answer. So this is pretty simple. The same thing applies for subtraction. So let's say you have two complex numbers. This is the first one and this is the second one. Just like how you would add two real numbers, you just expand out the bracket. So you can think of this as minus 1 times this. So you just multiply inside by minus 1, you have minus c minus di, and that gives you a minus c as the first term, as the real part, plus I times b minus d. Very similar to real numbers for addition and subtraction. So you don't even need to actually remember these as formulae. You can just add them like real numbers to find what the value is. Okay, so we are done with addition and subtraction. Now let's move on to multiplication. Here is where it gets interesting and we actually start to utilize the properties, the important property of complex numbers, which is that I square is equal to minus 1. Let's do it here. We have a plus bi multiplied by c plus di. So these are two complex numbers and I want to find their product. Now I'm going to go ahead and multiply just like I would multiply two real numbers. That means the first term multiplied by the second term, just like you would multiply two real numbers. So let me show you quickly what would happen if I had to multiply two real numbers. Now if I have two real numbers a plus b multiplied by c plus d, I would just multiply a by the second term plus b multiplied by the second term. So this is exactly what I'm doing here. I've just considered this entire thing bi as the second half of the first term and this as the second half of the second term, and I have written it down just like as if they were real numbers. Now I can simplify a little by multiplying inside the bracket. This gives me ADI plus BCI if I just rearrange the terms a little bit, plus BD, and this is where it is fundamentally different from real numbers, because I times I is I squared, and if you remember, the defining property of these numbers is that I square is equal to -1. So here I square is equal to -1. Now let's look for which are the real parts and which are the complex parts. A multiplied by C is definitely a real number. This is definitely an imaginary number. Similarly, this is, because there's I. Whereas this is minus BD. It is a real number. So I'm going to write it as the real part. And now these are the two remaining terms. I can take out I common and write it as AD plus BC. So finally, the product of these two things is this. AC minus BD is the real part. So you can remember it like the real part of this multiplied by the real part of this, and you subtract the product of these two, B and D, and then you add I times AD, the outermost, plus the innermost. So if you want to remember it, that's how you remember it. But frankly, it's not necessary to remember, because you can just quickly derive this if you ever need a formula. And now we look at division. Okay, here I have two complex numbers, A plus B times I divided by C plus D times I. And I want to find the quotient of these two. So I want to divide the first one by the second. How will we proceed? We are going to use a method which you may have seen before. When we are talking about fractions of real numbers and we want to rationalize the denominator. So if you have A upon the square root of B, let's say, and you want to rationalize the denominator of this fraction, we use this trick, that is, we multiply by the square root of B upon the square root of B. So this is just the same as multiplying it by 1, because these two cancel off, and finally we are left with A times the square root of B upon B. And we have finally rationalized the denominator. We are going to use a very similar technique here, but before that, let me just show you how we rationalize the denominator of more complex fractions. So suppose I have something like this. If I have something like this and I want to rationalize the denominator, we multiply the denominator by what is called the conjugate of the denominator. That is just the sum of these two, just these two terms, but with a negative sign. That is the conjugate of this denominator. So we multiply this thing by the square root of B minus the square root of D, divide by the square root of B minus the square root of D. This square root of B minus square root of D is called the conjugate of this number. And frankly, the reason why we call this the conjugate, actually the name comes from complex numbers, from the theory of complex numbers. We will see later why exactly this is called the conjugate. But for now, just remember that this is the conjugate. And what happens when we multiply these two is that since we have the formula that, okay, let me use different letters. Since we know that x plus y multiplied by x minus y is equal to x square minus y square. This is the formula for real numbers, and as we will see later, it holds for complex numbers as well. We can rewrite the product of these two as b, because the square root of b square is just b minus d upon and the product of these two. So I'm not going to write them down, but just the product of these two terms. And as you can see, we have managed to rationalize the denominator here. We are going to use this concept of the multiplying by the conjugate like we did for real numbers in the case of complex numbers as well. Okay, so this thing, if I multiply by the conjugate of the denominator, the conjugate of this is just like as we have seen before, c minus di, c minus di. Now I'm going to multiply the two numerators together, and since these two are of the form as we saw the identity below, I can write this as c square minus di square, since di is the second term in this case. Okay, so let me just repeat it once again. Since I have something of the form x plus y multiplied by x minus y, I can write that as x square minus y square. And finally, if I simplify this using the previous formula that we saw, this is just AC minus BD plus I times AD plus BC divided by C square minus DI square. Just like we can multiply each term separately like real numbers, we do the same for imaginary numbers. So I have DI square is equal to D square multiplied by I square. Again, the characteristic property of imaginary numbers is that I square is equal to minus 1. So this whole thing is just AC minus BD plus I times AD plus BC upon C square. Since this is minus 1, we can write this as plus D square. And now finally, since it's more convenient to write complex numbers of the form x plus iy, we usually like to write these numbers in such standard form. So what I'm going to do is I'm going to separate this denominator, since there's a plus sign in the middle, and I'm going to write it as follows. So I'm going to just separate it out like this, so that I have this entire thing as the real part, and this thing as the imaginary part. And now I have the number in this standard form, and so it will become easier to use this number. Now we'll see a few examples of these properties. Okay, the first question is that the first problem is that we need to multiply these two complex numbers. Now you can either use the formula, or you can just, like how we derived the formula, you can multiply out these two terms. I'm just going to directly input the values into the formula, but you can do it anyway. So the formula just says multiply the first term by, so if this is A, then this is C. Subtract from that B times D. So B in this case is 2, D in this case is minus 1. That's that's the real part, plus I multiplied by the outer 2, so 1 times minus 1, plus the product of the inner 2, that's 2 times 3. Now just simplifying it, 3 minus 2 times minus 1 is plus 2, plus I times minus 1 times 1 is minus 1. 2 times 3 is 6. We have 5 plus I, and minus 1 plus 6 gives us 5. We have 5 plus 5 times I. That is the product of these two complex numbers. Now we look at an example of division in complex numbers. Okay, now I want to divide these same two complex numbers which we just multiplied. So using the formula, we have A times C plus B times D. A is 1 times C is 3 plus B times D. B is 2, D is minus 1, divided by C square plus D square. That's 3 square plus D is minus 1 minus 1 square plus I times BC minus AD. So this is B and this is C. So BC minus AD divided by the same thing here. So 3 square plus minus 1 square. Now it's just a matter of simplifying it. This is 3 minus 2 over 3 square, which is 9. Minus 1 square is just 1. I times, we have 2 times 3, which is 6. Minus 1 times minus 1 is plus 1. Divided by same thing, plus 9 plus 1. 3 minus 2 is minus 1. Oh, I'm sorry. 3 minus 2 is 1. 9 plus 1 is 10. 6 plus 1 7. 9 plus 1 is 10. Now it's up to you whether you want to take out this 1 over 10 as a common factor and write this as 1 plus 7i, or you can just leave it in this form, since this is actually a standard form of complex numbers. It depends on you. I hope you have understood this example as well as all the previous other concepts. And don't forget, if you understood, to like and share this video. I'll see you in the next one. Bye for now.